Well, no, you don't have the quiz now, but this is going to be like, yeah, this is going to be like, all right, so I want you to add the following. Add. So plus 3 plus negative 12 plus negative 6 equals that. Okay? B. Square. This is square 15. Square 6.8. Okay? C. I want you to square root 25 and also 3 and also 2.8. Okay? Do those right now. Okay? I want you to simply add these integers, square these two values, find the square root of those values. Now, most of these you need some of these you need a calculator, some you don't. You shouldn't need a calculator there. You should need a calculator there. You will here. You don't need one there. You don't need one there. You don't need one. You need one here and here. Okay? This might be a little confusing. This is not a decimal point. It's a bullet. Okay? So let's do this right now. Okay? All right, what's the sum of plus 3, minus 12, and minus 6? What is it? Yes, Nora. What is it? Negative 15. That's correct. Now, let me say something about the first one. Are you ready? Write this down. You only add vectors. You don't subtract them. You're adding vectors. You add vectors. Vector sum. Clear? You're adding vectors. Clear? You're not saying plus 3 minus 12. You're saying this vector plus this vector plus this vector. So we're talking about vector sums. There's no such thing as subtraction. Subtraction doesn't really exist. Clear? It doesn't really exist. That is a negative sign. That's all it is. It could mean a negative sign placed relative to 0 and the number line. It can also mean additive inverse. Clear? What's this? What's this value? What's that value? How do you write it? How do you write the answer? Plus 15. That negative sign means additive inverse. I take the additive inverse of whatever's there, reading from left to right. That means additive inverse. So what's the additive inverse of negative?
Positive.
Positive. Clear? Are you sure?
Yes.
Okay. Yes?
But if it's positive, do you necessarily have to write the positive?
You have to write the positive sign. Yes, absolutely. Because we're going to talk about that after this is finished. Please remind me, okay? Vivian asks, do you actually have to write the positive sign? And the answer is yes. You should get used to that, always. Clear? If it's an integer. If it's a whole number, then no. In other words, how many erasures do I have? Positive one or just one? Just one. It's not a positive, it's one. Clear? It's not an integer. Clear? Okay. All right. What's 15 squared? What is 15 squared? 225. That is correct. Okay. What is 6.8 squared? Yes, Maren.
46.24.
You only need tens place unless otherwise noted. I think on the sheet I said hundreds place, and that's okay. So let's do hundreds place. That's very good, Maren. So what was it?
46.24.
46.24. Yeah. When in doubt, only use 3 or 4 significant figures, 3 or 4 numbers. Don't put every number off your calculator, because what will happen is this. One night when you're asleep and you're comfortable in your bed, all of a sudden you'll hear, "Open up! This is the significant figure police." They're very scary. They'll handcuff you, take you to significant figure police jail. So don't violate significant figures. Don't put all the significant figures. How many people feel very confident? The more numbers you put off the calculator, the more confident you are. It's in there somewhere, right? No, you don't do that, ever. Okay? It shows lack of confidence. Plus, the significant figure will come to the door, and when you hear 3 o'clock in the morning, you'll hear, "Open up! This is the significant figure police!" Don't let that happen. Is that clear? Excellent.
Too many numbers.
Yeah, you don't put, when in doubt, put 2 or 3 or 2, 3 or 4, when in doubt. Okay. Square root of 25, that's an obvious one. 5. Square root of 3, that's a good one to actually memorize. Yes. What is it? 1.73. Very good. You see what she did? She just gave me 3 significant figures. Excellent. Commendation from the significant figure police. She only gave me 3 significant figures for the square root of 3. Excellent. Well done. 1.73. Is that correct? Yes? Now, do me a favor. Square 1.73. Somebody just 1.73, square that. What do you get, Vivian?
2.99.
2.99. That's calculator error. That's round-off error. As opposed to reading a scale, which is systematic error. That's reading error. It's a little different from calculator error. Clear? Like you're reading a plot on a graph. Is it 2.8 or 2.6? That has to do with precision. It's very different. You trust me. If somebody asks you, do you want to learn about precision, you know what you say to them?
No.
No, thank you. I'll do without it, okay? But when you're in chemistry, you take chemistry class, we have these big, long lessons about precision and accuracy, and it's very involved. But let's not worry about that now. But reading a graph where I'm looking, if it's 2.8 or 2.7, that's called precision and generating significant figures and accuracy, and you just don't want to know, okay? So when in doubt, 3 or 4, 2's fine, okay? So what about 2.8? Mary?
1.67.
1.67. Excellent. Excellent. 1.67. You guys are doing very well. Very well. You're going to get 100 on this quiz. Let's do this one. Okay? I have a point there. Okay? What's the slope of the line? What's the slope of the line? Alyssa, what's the slope of that line? I picked on you a lot the day before. We'll see if you remember. What's the slope of this line? It goes through 0, 0. What's the slope of that line? This is point 10, 300. Is that on?
Yeah.
Excellent. Can you tell me the slope of that line, Alyssa? 300 over 10. Excellent. You want to reduce that for me a little bit? Use your internal calculator. 30 divided by 10 is? 300 divided by 10 is? What is it? I'm not laughing at you. Well, yeah, I am actually, because you know the answer and you're being very goofy. 30 divided by 10 equals? 30. Is that what you're going to say? Okay, I really didn't hear you that time. Excellent. 30. Yes. Excellent. What's the error? Sorry, Greta, you were like there. That's fine. Mental math, though. What's the worst thing to happen in mental math? What's the absolute worst thing? You're wrong. They don't have mental math police, so don't worry about it. Significant figure police are out there, you know, but mental math police, they don't have them, so it's okay to do mental math wrong. Okay, so what's the area under the curve?
Oh,
Under the plots. Under the curve, you sound too intelligent. Please don't say that, because people have too many expectations. If you say, I know the area under the curve, they're going to give you really hard things to do. Do you really want to do hard things? At a 7th grade? No, you don't want to sound that intelligent yet. Okay. Marion, you already do. You be quiet. Laura, what's the area under the curve? 1,500. Excellent. Well, how did she get that? How did she get that?
She multiplied the height by the base.
Yeah. 1/2 the base times the height, 1/2 xy. Right? Which equals 300 times 10 is 3,000. Half of that would be 1,500, correct? You get it? Yes? Are you with me? All right, now, we have 2 more things to do today. I'm actually going to do several worksheets, okay? Several worksheets. Is that a copy of the worksheets here? Is this yours or this is just extra? Is that yours? Is that yours? Okay, let me borrow them for a moment there, Greta. Thank you. All right. Now, you're going to say to me, this is like really hard and I hate it. But remember, in 7th grade physics, there is no math. It's only calculators. Understood? There's adding, subtracting, multiplying, dividing, but there's no math. All right, say after me. You ready? There is no math in physics. Say that.
There is no math.
All right, 1, 2, 3, everybody. Alyssa, Julie, 1, 2, 3. There is no math in physics. On the count of 3. You're going to say alone. 1, 2, 3.
There is no math in physics.
There is no math in physics. Excellent. Excellent. Now, let's do this. We're going to do worksheet. Open up to worksheet 8. Now we'll see, Professor, if I did these worksheets correctly.
Oh, yeah.
They look correct. The columns look different, but they look correct. All right. This is the equation. You ready? Okay. I know, it looks really hairy, doesn't it? How many people think it looks a little hairy? Raise your hand. It's been growing some mold. You ever see like really cool bread mold where it has little hairs growing out of it and, you know, gross. Isn't that gross? It has a little eyeball in the center of it that blinks at you when you try to butter it. You know, isn't that gross? Okay, excellent. So it's a little hairy. All right, what does this thing mean here? That's something that you got to see. What does that thing mean? Yeah, but what's a little dot there, a little open circle? What does that mean?
Multiply.
It means initial. You can either use that or I. This is pronounced naught. V naught. Fancy. I don't even know how to spell naught. Look that up in a dictionary, someone.
N-A-U-G-H-T.
Next time you see Mr. Nair, simply call him Mr. Dictionary, okay? Okay, Marion. You know about Merriam-Webster? Anybody ever hear Merriam-Webster the dictionary? He was kind of kooky. You know what he did? He simply artificially wanted to make American English different from British English, so he just made up words. And we just accept them today. Like he took letters out of words like color, and he just made up words to make them British.
I write all of the ones with the OU, that actually in American with O, I always write them with U.
Yes, exactly. Exactly. Merriam-Webster. Little kooky. Okay. So, we have the first one. What I have is, I have each individual thing here. Okay, let's do, well, number one is, everything is 0. So 0, 0. So what's the answer to number one?
0.
Everything is 0, okay. So number 2, it's going to be V naught equals 1, T equals 1, and A equals 0.2. Correct? Okay? Now, plug these values in to that equation. All right? Let's see who can do that first before we proceed. Try to do that yourself. And then I'll show you. I just want to see who can do this. Can you plug those numbers in? How many people think they can do it? Raise your hand. All right, shall I do it for you? You look a little stunned. Rowdy, how you doing there? You look a little stunned. Are you stunned? Okay, the dead parrot sketch. He's not dead, he's stunned. Okay, all right. So D equals 1, T equals 1, plus 1/2, 0.2, and then 1 squared. Right? What's the first term? What's 1 times 1? 1. What's 1/2 of 0.2? 0.1. What's 1 squared?
1.
So bring it over. What's 0.1 times 1?
1.
This is a calculator, guys.
1.1.
And what's 1 plus 0.1?
1.1.
That's it. Was that hard? You gotta use your calculator. You see why you need a calculator?
Yeah.
Shall we do another one?
Yeah.
Can I erase that?
No.
No? Well, why can't I erase it?
Because I'm going to copy.
You can take a picture of it. You know what? Copy it down quickly. But you should be copying it. Actually, it's on the film, so it doesn't matter. Right?
Oh, yeah.
Okay? All right. Let's do another one. Pick one.
Number
14?
Number 9.
Number 9. Okay.
That's my lucky number.
Number 9. So V naught equals 9.4. T equals 8. And A equals 1.04. Okay? Shall we do this together as well?
Yeah.
Okay? So, we're going to say D equals V naught is 9.4. You see that? So 9.4. Notice something to help you out. We're not putting in unit labels yet. Okay? Unit labels like meters per second for velocity, seconds for time, acceleration is meters per second squared. When we do that, you'll see that those letters are treated mathematically. Clear? The rules that you follow with numbers, you follow the same rules with the unit labels with letters. Clear? They're governed by the same set of rules. That's like an American in Paris. Is the American responsible for French laws? They're not.
Yes.
Of course they are. So letters are with numbers, so they govern the same. Do you get it? Okay. So T is going to be 8 plus 1/2, 1.04 times what? 8. Now let your calculator do the work for you. Do it in 2 parts. Do this part and then do this part. This is squared. Okay. Divide by 2. Or multiply by 0.5. That's 1/2. Okay? Guys, that's a very good question Sky came up with. How do you multiply by 1/2 with a calculator? And if you're not doing math? Well, 1/2 is the same as 0.5. Clear? Okay? It's a good point. Can you get it? Shall I tell a story?
Yeah.
I remember when I was in 7th grade, I had a nun. I went to a Catholic school. Her name was Sister Karina, and she's still around. She was my favorite teacher ever. She's still around. I correspond with her every once in a while. She's 193 years old, but she's still around. I'm kidding.
Oh.
You know, to me, she looked like an old person when I was a kid. You know, I was like 13 when I had her. I was your age. But she's only like I'm 58, and she's like 70. So she was in her mid-20s when I had her. You know, it's like she's an adult. We're like peers. It's weird.
She looks like an old woman?
No, she doesn't look. She looks like she's 70. She looks great for her age, actually.
She's still alive?
Yeah.
Yeah, she is.
Sure. She's a young woman. 70's not old. You think 70's old?
Oh, she's 70.
My mother is 98. Of course, she thinks she's Teddy Roosevelt, but she's 98, and she's very sweet. She's always happy.
Yay.
She thanks everybody for everything, even if they didn't do anything. She says, "Thank you very much. Thank you. Thank you."
If you're happy, you live longer.
If you're happy, you live longer. Yeah, being evil takes a lot of energy. Do you know that? It takes a lot. To be mean and rotten, God, I don't have the time. To take over the world, I just don't have the time to take over the world. How many people feel like they have the time to take over the world? Anybody? Too much work, man. Too much work. Too much organization. All right, did we finish?
I got the wrong answer. Sky has mentioned.
Okay, remember, these answers are on the web.
The web.
The web.
Dun, dun.
The web. Okay? So what is it? So, shall we do it in parts? Okay. What's 9.4 times 8?
9.4 times 8.
75.2.
75.2. Excellent usage of significant figures.
It's the same.
Oh, that's what it said there. You could have lied and said, you know what I mean? So what did you get, Vivian?
75.2.
All right, let's do this in parts. 1/2 of 1.04 is what? 50.2, right? Isn't it?
Yeah.
Right?
Yeah.
50.2. What's 8 squared? What's 8 squared?
8 squared.
Did I make a mistake?
Oh, 64.
Did I make a mistake?
Half
8
of
squared is 64.
1.04 is not,
0.
I did the same thing, that's why I left.
Thank you. Thank you. Made a mistake. Excellent. Extra credit. Extra credit. Excellent. Absolutely. Absolutely. So, what is 8 squared?
64.
64. All right, so what is 0.52 times 64?
33.2.
30, what?
33.2.
And then 75.2. So distance will equal, so it'd be 108.4, is that right?
Yeah, 108.4.
Yes? You get that? All right. Is that right or no?
Can I take a picture?
What's wrong? Vivian, what's wrong?
No, because I got that, but I thought it was wrong.
Oh, you got it, but you thought it was wrong. Excellent.
Mr. Darcy, can I take a picture?
Of course, you may take a picture of it, absolutely. This is the year 2014. Instead of using tape recorders, we use cameras to take pictures of notes on the board. Even from 20 feet away, Alyssa's taking a picture. Excellent. You get it? Okay. So how many people understand that this is a recipe? Do you understand that? Anybody ever make a cake successfully?
Yes.
Yeah. So don't you follow a recipe? Here's the recipe.
No,
Here are the ingredients. Right? That's all.
I just follow. And then you put them together in the right way.
And you put them together in the right way. Exactly.
Okay, can we try the next one? So I just want to make sure I'm doing it right.
We'll try one more, and then we've got to do other things.
Let's do number 3.
Do number 3.
Wait, no, don't even see
No, not that.
Victoria, I'll
Wait,
text
no,
you.
no, no, no.
Victoria, I'll text you the picture.
No,
All right.
wait, I'm just at the last one.
Okay. We've got to wait for Victoria.
Victoria, I can.
She's very retro, very old school. She's actually taking notes. Amazing.
Oh my gosh.
It's a Canadian thing, I know.
No, it's not.
They like to live in the past. Did I say that out loud? Sorry.
Why would you say
My
that?
Canadian brethren.
I take a lot of.
Canadians are much nicer than Americans. I mean, sorry, American
Yeah.
people, but they
That
are
makes
like,
so
you
much
know,
fun of the Canadians.
Canadians are just so sweet. You ever been to Montreal? It's an unnatural looking city. It's so clean.
So mean.
Looks like it's just been built.
I like New Jersey.
You like New Jersey?
Yeah, when I'm going.
I was born in New Jersey. I was born
I'm
in
going
Hoboken.
to Princeton and hopefully.
All right. So let's do number 3. Is that it?
Yes.
And then we'll move on to something else.
I'm gonna check my answers. Wait, I need the guide so. Cause this.
All right. So 2.2. Two and 0.32. All right, do that one, and I'll talk about velocity or something.
Okay. Wait, I need the picture.
You can take a picture.
No, I need the picture.
You need the picture?
I have like a formula, so
All right.
we can
I got you.
plug these numbers in.
I got you. Plug this one. Plug that one in. Now, how many people are watching these videos with their parents to making sure? Now, remember, I know you don't want to watch a video with your parents. It's kind of boring, you know. But you know they know more about physics than they think they do, so they can help you. You know everything about physics there is right now.
That is never.
You know physics. You just have to organize it. That's the problem. Teaching physics is easy. It's the only course I teach where everyone knows the material before I teach it. Weird, huh? What year was the end of World War II?
1960.
Very good. Excellent, excellent, excellent. But that's a date you look up or you remember, right? Right? Physics is something you do every day. What's inertia, for instance?
It's the force in space that keeps an object moving in the same direction.
Well, inertia is the same as mass. An object, a mass, is going to stay at rest unless acted upon by an external force, right? So it's going to move. Here it is, and I'm just going to move it. I'm going to put a force on it. It's going to move, right? Or if I have an object in space, it'll keep moving unless it crashes into the moon or the earth, and then it will stop. So something that's moving will always move unless something stops it. So inertia is an object in motion will stay in motion, an object at rest will stay at rest unless either are acted upon by an external force. You knew that, didn't you? Of course you knew that, right?
I got an answer.
What happens when you step on the accelerator in your car?
Go for
You
it.
accelerate. Didn't you know that? Of course you knew that. Did you get it? Did you finish?
I don't think it's right, but I got 18.
All right, let's plug it in. So 2.2 times 2 plus 1/2 0.32 times 2 squared. 2 times 2.2 is 4.4. What's 1/2 of 0.32? 0.16. Is that right? 0.16 times 4. 4.4. 4 times 0.16. 4 times 16 is 64, right? So what would that be? What's 4 times 0.16? 0.64, right? Isn't it?
Yes.
0.64. So what's the answer?
4.
5. What is, put in your calculator. 4.4 plus 0.64.
5.84.
5. Did you put in your calculator?
Gotta take it.
4.4 plus 0.64. 5.04. Marin, check your calculation.
4.4 plus decimal 64 equals 5 decimal.
Marin, put it in again and try it again. Remember, this is a calculator thing. Nobody should be looking at me like, how did you do that? It's your calculator that does it. You just got to put the numbers in. Clear? Are we all right? Now, Maren, you get it? Yes, Vivian.
You do a 4.4 plus 6.4 times something divided by 2.
Divided by 2. Why am I dividing it by 2? I already divided 0.32 to get 0.16.
Yeah, but is 5.4 the answer?
5.04. Do you have a calculator?
Yeah, then I divided it by 2.
Why did you divide it by 2 at the end? No, but why?
Because the other number was too big, so.
No, you don't divide it by 2 because it looks better. You divide it by 2 because you were instructed to do so based on the recipe, based on the equation. You see, this 1/2 here I already used. I can't use it twice. 1/2 of 0.32 is 0.16, correct? 2 squared is 4. 0.16 plus 4 is 0.64, right? 0.16 times 4 is 0.64. 0.64 and 4.4 is 5.04. Did you get that, Maren?
Yeah, I got it.
You got it. Good. Now, before we move on, let me show you something. How many people, and I'm not giving you a quiz yet, but how many people understand plugging into an equation? How many people understand the idea? Okay? I'm not asking you to do a quiz on it. I'm asking you to follow along. Iman, can you follow it, kind of? You just plug in the numbers, okay? Well, there's going to be, that's worksheet 8. Now, there's going to be other worksheets where you're going to plug in. And you got to know T equals 2D over A. That's worksheet 9. Worksheet 10 is VF, final, equals V0 plus AT. There's that naught again, means initial. Worksheet 11 is a really cranky looking one. And then the last one, D equals VF squared minus 4 over 2A. So this is worksheet 12. Okay, this is worksheet 12. This is worksheet 11, 10, 9, 8. If anybody comes after school, let's see, what's a good day to stay after school? Tuesday? Is Tuesday good?
No.
What day's good?
Wednesday.
Wednesday, what day? Wednesday. I'll stay after school on Wednesday. If anybody comes after school on Wednesday and demonstrates to me, a proficiency, you know what that means? Proficiency? You can do it. Proficiency is you can do it, right? Demonstrates a proficiency to plug in numbers to these equations, meaning you can do these worksheets and you demonstrate that to me, I will give you extra credit. Clear? Understood? I will give you extra credit on your grade. And the better you demonstrate the proficiency, the more extra credit you're going to get. Is wide open. Clear? How many people feel they need extra credit? How many people feel they will need extra credits? Yeah, I thought so. So, come after school on Wednesday and we can do that. Enough said?
Yes.
I want to move on. Okay? All right. Now, how many people have ever been in a car?
I haven't.
Okay.
I've never been.
How many people have ever been on a bus? I'll bet you people have never been on a bus. Anybody never been on a bus? Raise your hand. You ever been on a bus? It's okay. Have you ever been on a bus?
Yes, I have.
Train or bus or something? Okay. Let's say that the bus is going 60 kilometers per hour. Okay? To the right. We're going to say that that's east. Right? So, What's the speed of the bus? What's the speed of the bus?
60 kilometers per hour.
60 kilometers per hour. That's the speed. That's the speed. Clear? The speed is the magnitude. The speed is the magnitude of the how fast you're going. What's the velocity? What's the velocity? What's the velocity? What's the difference? Have you been doing your reading? Remember I gave you that? How many people have done their outline? What's the velocity? Yes. Anybody? The velocity is everything. Okay? Yes? Now, we're going to do a special side lesson. Okay? Don't you see that that's a little confusing? How many people think that's confusing? Raise your hand. Speed and velocity, blah, 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 right? How many people find that a little weird? Okay, good. Before I did this lesson, I wanted to establish that there's some confusion here. Okay? Yes? Okay. I've got to explain two quantities as a result of that, two ideas. Okay? That's confusing. Yes? Okay. So, we have an answer. We have an answer. The answer is vector scaling. Okay? A vector has magnitude and direction. A scalar has only magnitude. I have one marker. One marker. One marker. Is that plus one marker, negative one marker, or just one?
Just one.
Just one. One marker. What kind of numbers are used to illustrate scalar? What kind of numbers?
Just numbers.
There are two types of numbers that are used to illustrate them. Yes?
Whole numbers.
Whole numbers. Whole numbers. What else?
Integers.
No, not integers.
Negative numbers.
Whole numbers. What else?
Negative numbers.
Counting numbers. You know what a counting number is? What's a counting number? What's the difference between whole numbers and counting numbers, and why the big deal?
Whole numbers are like just numbers. Like
What's,
whole numbers.
what came first, whole numbers or counting numbers?
Counting numbers.
And what did you add? What's a whole number?
A whole number is like it could be like
No, there's a very simple answer.
above zero.
What is it? I can't hear you, hon.
A number above zero.
Above zero. No, that's counting numbers. A whole number includes zero. Yes? Counting numbers. Whole numbers. Yes? Correct? Yes. What else? Let's expand on this. Can't 0.5 or root 2 be used as well? No?